Welcome. Today we'll be looking at mole concepts. This is the best explanation of mole concepts and the calculations of mole mass-mole relationship that you see out there. I'm not going to lie to you, this is the best explanation. I'll try to break it to a more relatable form than you see out there as possible. So follow, just follow. You won't regret watching this video. So what is a mole? We say a mole is the amount of a chemical substance that contains as many elementary units as there are atoms in 12 grams of carbon-12. So the keyword here is as many elementary units. So it's the amount of a chemical substance. So the amount is another keyword. So a mole is the amount of a chemical substance that contains as many elementary units as there are atoms in 12 grams of carbon-12. And what is that elementary unit that we are talking about? Those elementary units, they can be what? Your atoms. As many atoms as they are. They can be molecules. They can be ions. They can be electrons. So these ones, they are elementary units. So as many elementary units as there are atoms in 12 grams of carbon-12. So we are using 12 grams of carbon-12 as our reference point. And what is that, the number? What is that as many here? That as many is talking about your Avogadro's constant. Your Avogadro's constant, which is represented as L is equal to 6.02 times 10 raised to the power 23. So just hold it in your mind. So we can say that a mole is the amount of chemical substance that contains 6.02 times 10 raised to the power 23 units as there are atoms in 12 grams of carbon-12. So now let's look at what that means for us. So that can mean that if 1 mole of carbon atoms weigh 12 grams, so this is your mass number or the weight atomic mass of this atom. So if 1 mole of carbon atom weigh 12 grams, then 1 mole of oxygen atoms will weigh 16 grams. But they will all contain the same number of what? Elementary units. That means as 1 mole of carbon weighs 12 grams and contains 6.02 times 10 to the power 23 atoms. So also 1 mole of oxygen atom will weigh 16 grams and still contains 6.02 times 10 to the power 23. Like I said, take note, as many elementary units. That is your keyword. Then 1 mole of sodium will also weigh 23 grams, but also contains 6.02 times 10 to the power 23 atoms. So let me use a very simple analogy. Let's look at these different currencies. We have what? We have 1 naira. We have 1 naira. We have $1. And we have what? And we have 1 pound. So out of these 3 currencies, which of them weighs the least? Naira, obviously. So let's say naira is our carbon. So let's say naira weighs 12 grams, for instance. And let's say dollar weighs 16 grams. Like if you weigh them, and dollar weighs more, so the dollar has more value. Pounds weighs, let's say 23 grams. So that is to say, if you want to use 1 naira to buy meat, you can only buy 12 grams of meat. If you use $1, you can buy 16 grams of meat. If you use £1, you can buy 23 grams of meat. You get the idea? So that is it. But this is not where I want to get to. 1 naira weighs 12 grams, but contains how many kobo? Contains what? 100 kobo. So 1 naira weighs 12 grams and contains 100 kobo. $1 weighs 16 grams and contains, what is the elementary unit of dollar? Cents. So it contains how many cents? 100 cents. So you can see that the number is not changing. 100 cents. So as many elementary units. So I see it. 100 kobo, 100 cents. Let's look at pound. And contains how many pounds? And contains 100 pence. Pence is the elementary unit of what? Pound. So and contain 100 pence. So basically this is what the mole concept is all about. So the mole is like a standard. So yes, the mole is a standard. Just the way 1 naira contains 100 kobo and $1 contains 100 cents and 1 pound contains 100 pence. So also the quantity of the atoms in each of these elements are the same. 1 mole of carbon contains 6.02 times 10 raised to the power 23 atoms. 1 mole of oxygen contains what? 6.02 times 10 raised to the power 23 atoms, but their masses are what? Different. Do you understand? So that is what the mole concept is. So because of this relationship that we are able to find the relationship between different atoms in a chemical reaction. I hope this explains it. So let's go over the definition one last time. They say a mole is the amount of a chemical substance that contains as many, this is the word, as many, and that many I said what is your Avogadro's constant. So that contains, for example, 6.02 times 10 to the power 23 atoms. So as many elementary units, this is the number normally, as there are atoms in 12 grams of carbon 12. So basically that is what a mole is. I hope this explains. Watch this video over and over again. You get the concept will still better. So let's move on. Let's find the relationship between mass, mole and Avogadro's constant. We will use a triangular relationship where we have 1 mole, we have the Avogadro's constant, Avogadro's constant, that is 6.02 times 10 raised to the power 23. This is a constant you must know. Particles, take notes, it does not have units. Particles, and I told you that those elementary particles can be your what? Your atoms, your molecules, your ions, your electrons. They are all particles. Just the way your cents, your kobo, your pence, they are all elementary what? Currencies. So that is it then. Atomic mass. So there is a relationship between these three guys, and we are going to see it just now. So 1 mole is equal to 6.02 times 10 to the power 23 atoms, molecules of anything is equal to 1 mole of that substance. So this equals, and 1 mole of a substance contains this guy, so contains 6.02 times 10 to the power 23. Then 1 mole of a substance weigh your atomic mass, which is the same thing as your mass number, but this time around your mass number with a unit, which is gram. So it weighs your atomic mass, while your atomic mass is equal to 1 mole of that substance. For example, the atomic mass of carbon is 12 gram. It is equal to what? 1 mole of carbon. So equals. And lastly, 6.02 times 10 to the power 23 particles weighs the atomic mass. So the weight of 6.02 times 10 to the power 3 particles, and just the way the weight of 100 cents we saw was what your was the number there. What is that number again? 16 gram. So that is why 100 pence was weighing what? 23 grams. So 23 grams can be likened to what the atomic mass of the pence, while 16 grams, 23 grams can be likened to the atomic mass of pound, while 16 grams can be likened to the atomic mass of what? $1 basically. So they have different weights, but the number of particles are what? The same, as long as we are talking about mole. So that's what I want you to understand. What makes mole mole is the what? Number of particles. The number of particles in that amount of substance. Okay, why this contains so this is the interrelationship in title of figure. This interrelationship between mass, mole, and Avogadro constant. Avogadro constant. So without wasting time, we'll move on to the calculation part. Yes.